Oh, sorry, didn't see you there. Hi, my name's Aaron, and just a few weeks ago, my company announced this new project called Reflect. Reflect is a new way to build web applications that are multiplayer, like Figma, Notion, Google Spreadsheets, things where a bunch of people can be editing the same document and everybody sees their changes live in real time. Um, and of course, it's been possible to build these kind of things in the past. There are open source libraries for this. There are these data structures called CRDTs, and there are even commercial solutions. But what makes Reflect different from the existing options is its approach to sync. The way that existing options usually work is that they'll give you a few data types. Like, for example, they might give you list and map. And for each of those data types, they'll give you a few operations. Like for list, you might get insert and delete. But the problem is you only get these few operations to work with. You cannot add or extend them. So say, for example, you want to have a shared list in your application and multiple people are going to be edited, but you need to restrict this list to only 100 items. There's actually no way to do that in CRDTs or existing systems. Or say that you want to have a shared list and anybody can add items to it, but you can only edit items that you yourself added. That's a pretty common thing that a lot of applications want to do. You can only edit content you created. But surprisingly, with CRDTs and with most existing solutions to multiplayer, there's no way to implement this kind of logic. So what makes Reflect really different than these existing systems is that it gives you a way to build your own operations. Rather than just a few data types and a few operations, Reflect gives you just one data type, which is JSON, and you can put anything in Reflect that's JSON. And as for operations, you can build as many operations as you want, and you build them using JavaScript, and they can do whatever JavaScript can do. So you can build your own custom business logic, you can build your own custom authorization rules, you can build your own custom validation, you can even build your own data structures like trees and graphs and all the operations that are needed to work on those data structures. So it's a much more flexible and sort of productive system, but it's also like really fun to use. So I thought in this video, I'll give you a quick demo of how to build a Reflect app, show you some of the moving pieces, and sort of get you introduced to the concepts so that if you want to build your own Reflect app, you'll know how to get started. Let's dive in. So to get started with Reflect, go to reflect.net, click Get Started, click Hello Reflect, and this takes you to hello.reflect.net, which is our documentation site. There's basically two ways to get started with Reflect. The first is to scaffold a new project. And this is basically like any other scaffolding tool you've seen. There's a command, reflect create, copy this into your terminal. Takes about 15 seconds to run. And once it's done, you can CD into the app and run it. You can open it in two tabs. And you've got a 60 frames per second, super crisp multiplayer counter. You can take this app and you can fork it, build something new. And when you like what you've made, you can publish it to our web service using Reflect Publish. And again, this takes about 15 seconds. So now we have a backend running at this location. Let's run the front end again. And now we get the same experience. But if we open the network inspector, we can see that it's actually talking to a remote server. So you could take this front end, you could upload it to Vercel, Cloudflare, Render, whatever you want, and you'll have a live multiplayer app. So scaffolding is a great way to start a new project, start a new Reflect project. It's really fast and easy. But what I'm going to focus on in this video is actually the other option, which is adding Reflect to an existing project. And the reason why is because rather than giving you a project that is like fully functional and already set up, these instructions walk through how to add Reflect to an existing project step by step. And so it's a little bit more educational and you can see more of the moving pieces and how they fit together. So what we're going to do first is create a new empty React app just using Vite. I will again call it my app. I'm going to choose React and TypeScript. There's no particular reason to choose React or TypeScript. Reflect works with any front-end framework, and you don't even have to use Vite. This is just something to install Reflect into. Installed my dependencies. Then once that's done, I can run the app. And I've got the basic React template app that is a counter. And again, this has no reflect in it. This is just a plain old counter using useState. So if I refresh the app, it goes back to 0. Of course, it's not persistent and it's not multiplayer. So let's fix that. Let's change this into a multiplayer counter using reflect. The first instruction to really get started adding reflect to an existing project is to use the reflect init command of the CLI. So let's do that. And what this does is 3 things. It installs reflect as a dependency, it generates a reflect configuration file, and it generates a minimal reflect server in the reflect directory. Let's take a look. So here we've added reflect as dependency. We have generated this config file, and we have our reflect directory. And you're probably wondering what this reflect directory is about and what a reflect server is. I'm going to come back to this, but let's carry on with the rest of the instructions first. All right, coming back to our instructions, we have run init and installed reflect. These next instructions are just explaining the files that got added, so I'm going to skip over that. And the next real instruction is to instantiate reflect. So I'm going to copy this code, find a file to put reflect into. We'll use app.tsx. And we're going to import the reflect class from the reflect package. I'm going to comment out the mutators for a second and come back to those. And then that leaves us with 3 parameters. So the server is the server that you want to store data at. Reflect ships with a fully local dev server, and it runs on 8080, so that's why that's there. The room ID is the room that you want to put the data into or connect to. And reflect is room based, so you connect to a room with the client, and all the people who are in the same room at the same time see the same data, and changes replicate live in real time between those users. And then that leaves user ID, which is required for authorization. So if in most applications you'll have a logged in user, if your application is anonymous and you don't have users, you can either put anon here, or you could put like a random ID, like with the nano ID package or something like that. All right, let's talk about mutators. Mutators are the core of reflect, and they are how data gets changed. What they are specifically is their JavaScript functions. Earlier, I said that what makes reflect different is that you can define your own operations and you can define them using JavaScript. Mutators are how that happens. You define a mutator, you give it whatever parameters you want, and then you implement the logic for that mutator. And you can use all of JavaScript to do that. Earlier, when we ran the init command, it generated this directory, and it generated this sample mutator, which performs increment. And as you can see, every mutator as its first parameter takes this thing called write transaction, which comes from the reflect package. And what this is it's the way that a mutator gets access to the data in reflect while it's running. So remember, reflect data is just JSON. It's a map of key value pairs where the values are JSON. And so at this lowest level, when you're inside a mutator, the way you can interact with reflect data is you can read keys from that big map. You can write entries to the map. You can also like delete entries or scan the entries. And that's how you read and write from reflect. The second parameter to every mutator is up to the developer. So you're defining the mutator, you define what the parameters are. In this case, we're implementing increment, so the parameters that we've chosen are the key to write the counter to, and the delta, how much to count by. Of course, this is JavaScript. The whole point here is that we can implement whatever mutator we want. So we can change this. Let's say that we decide that this should increment, but it should clamp at a certain value, like it can only count up to 100. We can easily do that just using JavaScript built-ins like this. And it works perfectly, and it's going to merge if people merge correctly, if people do this on multiple computers, and it won't ever go over 100. Or say that instead of clamping at 100, we want to roll over at 100, so it should go back to 0. Well, we can easily do that as well by just using simple JavaScript. Something like this. Or let's say that when we want to multiply instead of add, but only if the shift key is down. We could do that by adding a new parameter to our mutator, like this, that indicates whether the shift key is down. something like that. Or let's say that we want to have this behavior where the shift key makes it multiply, but only if the user is an admin. Well, Reflect has a built-in concept of authorization, and when a user authenticates to the system, you as the developer get the chance to say, to attach extra data to their identity, and you could define things like admin. So you could even do things like where is admin is just a special piece of data that you define as a developer. So you can see this is really a quite flexible system that enables you to implement all kinds of custom logic in your mutators that does sort of like arbitrary things. Now, some people might be listening to this and thinking, hey, wait a second. What happens if two different clients run mutators at the same time? Can they clobber each other? Could we lose an increment operation? And the answer is no, you can't. And the reason why is because even though mutators do run concurrently on different clients at the same time, they get sent to the server to get rerun. And there they get serialized and run sequentially, one after the next. If you want to, we're going to talk more about this in a few minutes, but if you'd like to learn all the details at a lower level, just go to our documentation site and click on this link in the sidebar, what the multiplayer web can learn from video games. This is a blog post that describes how our system works at a lower level, including these details. All right, now popping back up to the constructor, we take those mutators that we defined in the other file, we pass them into Reflect, and once we've done that, we can access them through r.mutate. There's increment, the one we defined, and notice that it's completely type safe. It picked up the parameter type from the definition. And also notice that there's only one parameter. We don't pass the write transaction here because Reflect itself passes that. So now that we've got increment, let's go ahead and update our onClick handler. The old onClick handler just, of course, called setState. We'll define a new onClick helper that calls our increment function, increment. We'll use the key counter and the delta 1. And then we can just replace this with our helper. And that's all. We've now updated the multiplayer state. All right, now all that's left is to render this data that's being stored inside Reflect. We're not going to need this use state anymore, so let's delete that. And we'll delete the import. Now, what we want to do is we want to actually subscribe to this key inside Reflect. We want to know when it changes so that we can re-render our app. Reflect actually has a subscribe method built in. And the way it works is you pass it a function, which is called a query function. And you can do anything you want inside the query function. You can read from Reflect. So for example, you could do like a rate counter like this. And Reflect is going to rerun this function whenever the data it depends on inside Reflect changes. So whenever the function might have different result, it gets rerun. And then the second parameter subscribe is the callback function. So you put something in here like this, and this function is going to get called whenever the query function changes, whenever the result changes. So you could do something with the data. Now, this will work fine in this app, but for React, we have this wrapped up into a hook called useSubscribe, which is a little bit more convenient. So we can just do const count equals useSubscribe. The first parameter is Reflect. The second parameter is that query function, which in this case is just this. We're just going to read that key, and then a default value. And if you want to make this like a little bit more ergonomic, you can specify a type right here of the data you expect to get out instead of just any JSON data. So now we have number or undefined. So that's it. We're now rendering the data from inside Reflect. We're updating it, and this should work as a multiplayer app. Let's give it a shot. All right, so going back to our terminal, we can run npx reflect dev to start the local dev server. And in another tab, we can run npm run dev to start the Vite UI server. And go ahead and open this in a tab. Open it in another tab. And you can see we have a multiplayer counter. And if we refresh, it's persisted. And we could even hold down the enter key while the button's focused, and you see we have a 60 frames per second synchronized multiplayer counter, which is pretty cool with Reflect. Of course, this is running locally, but we can easily run it remote on the web by just calling publish again. And just like before, this is going to push this Reflect backend to our server, and it will run live on reflect.net, and then you could publish the front end to Vercel or Render or Cloudflare or wherever, and you'll have a multiplayer app live on the web. All right, so that's that. We built a simple multiplayer app using Reflect. We started with a basic React template and added Reflect to it step by step. And along the way, we learned about Reflect mutators and how they sort of provide the flexibility that makes Reflect different from existing solutions. If you have any more questions, you can, of course, visit the website, hello.reflect.net, or just reach out and say hi. You can find us at discord.reflect.net, online at hello.reflect, or you can send us an email. We're happy to answer questions and talk to you about maybe whether Reflect is the right solution for your project. Thanks a lot for listening, and have a great day.